Okay, let's go ahead and get started, please. All right, so we're going to begin Module 4 today. Module 4 is, we're moving into the second unit, actually, with some more advanced C topics. I just want to reiterate one last time, I know you might be getting sick of hearing me say this, but if you'd rather hang back and spend more time reviewing Modules 1 through 3, now is a great time to do that. If you're in it with me for Module 4 stuff, that's also great as well, so welcome. To Module 4. Let's see if I can get this to behave a little better for me. We are going to be doing a lot of fun stuff today. There we go. That looks a little bit better. And then, of course, I am recording right now, so you can always come back and watch these on your own time whenever you get to them if you need to. So, alrighty, let's go ahead and begin. As usual, I'm going to start off with sort of some quick review questions and then turn you loose on some practice problems. First review, can somebody grab the lights actually for me over there? Somebody? We got it. All right. It's the one on the far left. Thank you. All right, first question. What is a pointer? Can somebody explain to me what a pointer is? Man, I started with a hard one, didn't I? Yeah. So there were a lot of things in that answer that I liked. You said a variable that points to an address in memory. I think a pointer actually really is an address, right? That's, I think, perhaps a better way of thinking about a pointer. A pointer is an address. A pointer is a location of something in memory, right? So pointers are pretty useful in C. They actually don't appear in many other languages, so C is sort of unique in that regard. We're going to kind of see why C uses them a little bit today. That's sort of my hope today, is to show you why C uses pointers. Okay, so the next question, what does the star operator do? Now this is maybe a trick question. I don't intend it to be a trick question. It's not multiplication, right? It's not multiplication. So what is it? Yeah. It's a dereferencing operator. So what does that mean? Dereferencing. What is a dereference? Yeah, go ahead. So if I have a pointer, right, a pointer is an address that's pointing to a value, the star operator will say, well, tell me what that actual value is at that address. So it's basically following the pointer, finding out where it points to, and then grabbing whatever that thing is and using that. It's called a dereference operation, right? What does the ampersand operator do? What is that? Yeah, so it's kind of the opposite. It's kind of the complement to the dereference. So that's going to tell us if I have a value, if I have an integer variable, and I use the ampersand operator, it will tell me the address where that variable lives, right? So it gets me the pointer, right? It gets me the reference to that particular value. So the star and the ampersand are kind of complementary to one another. Here is perhaps the hardest question that I've got on these slides today. I'm interested to hear what you guys think, or if you have an opinion. When should we use pointers? What's the big deal? Why do we have pointers? What's a good usage for pointers? Yeah? So say that you turn integers into... Right. So we can so it allows us to do things like modify parameters directly, right? Instead of, that's sort of looking ahead to some questions I'm going to ask you in a few minutes, but instead of taking in a copy of a value and then having to return a copy, we can actually modify the actual thing in place. We're going to talk about that in just a second. There are some other good reasons for using pointers. We're actually going to see some more reasons today. What are some other examples that we saw of pointer usage in the prep work for today? There was one phrase in particular that I was looking for. Yeah. Pointing to arrays, so we're getting warmer, right? We're getting warmer. In the past, when we use arrays, if I want to create an array, I have to know how big that array is ahead of time, right? I have to be able to tell it how big that array is. Well, what if that array, for some reason, goes beyond the size that I specified. I guessed that I needed 10 things, but I guessed wrong, and now I need 15 things, or I need 20 things, or 200 things instead. So I could, change the number, make the array bigger, and recompile it, right? But that's, then I might have the opposite problem. I've got this array with 200 elements, but then it turns out I only need 10, and I've got all this unused space, all this extra space. So pointers allow us to do something which is called dynamic allocation of memory. So pointers allow us to dynamically allocate memory, which means I only have to use memory when I need it. So if my array gets too big, I can create a new one that's a little bit bigger, store the stuff that I need to store, and then if it gets smaller for whatever reason, then I can give that space back. I can give that memory back. So I only ever use the actual amount of memory that I need, right? I'm not guessing that I need a huge amount of memory and then only using a fraction of it, for example. That's the example that we're actually going to see a little bit later on today. So that kind of leads us into these next questions. What does malloc do? What's the whole point of malloc? Yeah. It's a function that creates dynamic memory. Can we get a little bit more specific? That's a great answer. Can we get a little bit more specific? So we give it the size, and it tells us, or it comes back and gives us a chunk of memory that is that size that we can use, right? So that's what allows us to do dynamic memory allocation. I can actually go out and say, hey, I need a chunk of memory that is this big, and malloc will go out and find me a chunk of memory that's that big that I can use and give it back to me. But when it gives it back to me, it's going to give me back a pointer to that memory, right? I get a pointer back to that memory. So then size of, right, kind of goes hand in hand with malloc. What do we use size of for? What does it do? I think that's maybe a bit self-explanatory. It tells us how big things are. What is the units? If I say this has a size of 8 what? Yeah, it's in bytes, right? It's always in bytes. Always in bytes. So size of tells us how big something is in bytes, and we use this then for what purpose? Why is it useful? There's actually multiple usages for it. Yeah. Yeah, we use it with malloc. So if I'm creating an array of values, I need to tell it how much memory I need for those values. So I'll take the size that I need and pass that on to malloc so that malloc can give me the appropriate amount of memory back. Okay, a couple more review questions and then we'll do some practice problems. What does it mean to pass by value? What does that actually mean? What happens when I pass something by value? Yeah. I give it a copy. I give it a copy of whatever that thing is, right? So it's only a copy, which means if I change that value, what happens? If I change, so I pass something in by value and then I change that value, I'm actually changing the copy. So the original value remains intact, correct? The original value itself remains intact. Okay, so then passing by reference is kind of the complements to passing by value. What does it mean to pass by reference? What am I actually passing when I pass by reference? Yeah. The address, or the word that we're going to use, is a pointer, right? I'm passing in a pointer. I'm passing in something that points to a value. And then if I modify something through that pointer, that is permanently changed, correct? That value is permanently changed, right? So that's what it means to pass by reference versus passing by value. This is important. We saw actually a couple ways that this can work for or against us. We saw that swap function, where if we pass by value with swap, it didn't actually swap the values. It swaps the copies, but the original values remained where they were. And then you also saw string comparison. Strings are always passed by reference. So if I want to compare two strings, I can't really compare the references. I have to compare the actual letters, right? Which is a little bit different. So good. Any questions before we do some practice coding problems, some exercises? All righty. So we're going to write a few functions today. The first exercise seems simple on its face. I want you to write a function that prints out the contents of an array. We've done that before. That seems like old. Okay, I think it's going to go. Yep, here we go. Back in business. Okay. So once this loads, I'm going to create a new file for us to use to get started with this problem. In just a second here. Come on. There we go. Let's see, what should we call this? I'll call it array something or other, since we're dealing with arrays. And it's still going really slow. It's working, it's just working very slowly. Whoever's downloading movies. All right, there we go. I can make the file now. I'll call it array print or something like that, arrayprint.c. I don't know, I'm not too particularly concerned about the name. Just need to give it some kind of a name. We need some includes at the top, so we're probably going to need the usual suspects here, right? Including, let me make this a little bit bigger, get this out of the way. Including CS50x and standard IO.h, right? And now I want us to start to think about how we're going to write this function. So I need a main method. Okay, so I'll go ahead and throw a main method and see what it would feel like to use it, and then go back and write the function itself. So we don't have a function to call yet, but if I wanted to call the function, what might I say? So what's a good name for our function, for starters? We've got to give it a name. Maybe like print array. Let me try that. Print array. What are my inputs going to be to this guy? Do I need to give it any inputs? Probably an array, right? Probably an array. So I'll give it A, since I made it. Do I have any outputs? Do you think we're going to need any return values for this guy? I don't think so. I think this works pretty well. And so this will help us decide how we want to actually define this function as well. So we can come back down here, and now we can define this function. So we said there's no return type, so it's a return type of void, right? Print array is the name of this function. Now let's talk about the types of the input parameters. I don't want to use brackets anymore. So I use brackets up here. I fudged the rules a little bit and used brackets right there, but no more brackets. That's it. So how can I define these input parameters if I don't want to use brackets? What can I say? Int star A. What does this mean? Int star? What is that? It's a pointer, right? It's a pointer. Specifically, what is it pointing to in this case? What do we want it to be pointing to in this case? The first element, exactly. We want it to point to the first element of the array. Okay, so here's our function definition. And now, I'm not going to fill this out. I want to give you some time to see if you can figure this one out. But we can write a little bit of pseudocode, right? In fact, I think the pseudocode is going to be pretty similar to the way that we would do it if we were going to use brackets. We just can't use brackets. So what am I going to use? What am I going to need? What kind of structure am I going to need to print out this array? I'm sorry, I heard somebody say something. A loop. We're going to need a loop of some type. So for each element in A, print it out. I mean, that's really, when it comes to pseudocode, I think that's really all we need to worry about. For each element in A, print it out. The hard part here is how can we do this without using that bracket notation? That's the tricky part. So now I'm going to turn you loose on this problem. I will walk around, so flag me down if you need any help. We got some TAs, we got some mentors walking around as well. I'll give you a few minutes to work on this, and then we'll go through a solution together. All right? Alrighty, let's talk about this problem. I feel like maybe we're missing something in particular. I feel like maybe I didn't set you guys up wide enough. Does anybody know what I'm talking about? What are we missing here to help us out? String.h? Do we need string? What do we need strings for? My array is not a string. If you made an array that is a string, then yes, I agree wholeheartedly. But my array is not a string. It's an integer array, which is also what I listed here. But you're kind of on the right track. Well, we do need a prototype, sure. How do we, so I'm going to go to write this for loop, right? I'm going to set up my for loop. I'm going to say for int I equals 0, I less than what? So I know that it's 4, but what if I want this to work for, you know, a different array? Then I have to come down here and I have to change this 4 to something else. So that hard coding for works. It works, but I wish there would be a better way. We're actually going to see a better way in just a few minutes. I'll leave it like this for now, but think about this as we go through the rest of the exercises today. I want to get that 4 out of there by the end of the day today. I'm getting really tired of having to hard code those numbers in there. So I want to get that 4 out of there today somehow. All right, we'll go ahead and use it for now. And then now I just need to print out each element. So how can I do that without using brackets? What's the syntax? So I need a printf, right? Printf, I can say what? Inside the quotes, %i, and put a space in there too. And now what am I going to actually be printing out here? How can I say this? Somebody help me out? Yeah. Star paren a plus I. That should do the trick, right? That should do the trick. That'll work. This isn't the only way to do it, right? We could have done this a different way. Anybody know a different way we could have done this? Do I need I? Is I strictly necessary? I guess it is still necessary, but do I need to reference I here necessarily? I could just use A by itself. If I wanted to. I could just point out A, but then what would I have to do to make this work? Yeah, go ahead. I'd have to increment A. Now this is probably where it starts to feel a little strange. A, what's the type of A again? What's the type of A? It's an integer array or an integer pointer, right? It's really a pointer. So what does it mean when I say plus on it? What's actually happening when I do that? Yeah. It's going to go to the next element, right? It's going to go to the next chunk of memory for that particular pointer, right? So the way we had it up here originally works just fine. In fact, I might put it back that way. But I could also use the pointer directly. That's okay. Nothing wrong with that. I'm going to leave it like this for now. I got my prototype up here. Is there anything else that I'm missing? I don't think so. Does anybody else see anything I'm missing? Maybe a new line at the end, just because I'm a neat freak when it comes to my code. I don't think I'm missing anything else. Does anybody else see anything I'm missing? All right, so let's try it out. We're going to make, what did I call it, array print. Oh, thank you. I do need to save it. That would help. Make array print so it compiles. That's a good first step. And then we just go ahead and run it. And hey, there's our array. Beautiful. No brackets. At least no brackets down here, right? Are there any questions about what we've done? Any questions? So we're about to step it up a notch. So let's take a look at the next problem. Next problem is going to move things up a little bit. We're going to write a function that adds a single element to an array, which on its face seems fine, not too tricky. But we're going to assume that the array is full, that there are no empty spots in the array, and therefore we have to allocate space for that new element before we can add it in. So we have to put new space in there before we can add it in. We still can't use brackets, so we're going to create a second function to do this. Actually, Let me switch back and get us set up for this one. So instead of creating an array like this, I want to change my code to create a brand new empty array at first. So a very much empty array. And then I want to use my new function to add elements. But I want to make sure that there's only enough memory allocated to store exactly the number of elements that we have. I don't want to have any extra. I just want to have the exact amount, right? So let's think this through. Instead of creating the array the way we had it before, instead of creating the array that way, what are we going to do instead? How can we create an empty array? How can we create an array that has enough memory for 0 things in it? What are we going to do? We're going to use malloc. We're going to switch over and start using malloc, right? So what does that look like? I'm going to say malloc. Oops, I'm going to spell it correctly. What do I have to tell malloc to do its job? What do I have to tell malloc to do its job? I have to tell it the size. I have to tell it how much stuff, how much memory I want. In this case, I want to create an empty array with nothing in it. So the size is going to be 0. Seems a little strange, right? Seems a little strange, perhaps. There's one other mistake that I made. Does anybody see it? I have no name for it, so we can fix that. There's still a mistake. What does malloc give us? Yeah. Oh, did you have a different mistake? Well, we often do see size of in here, but I'm saying I want to malloc enough stuff for an empty array. I mean, if I really wanted to, I could say, times size of int here, but 0 times anything is going to be 0, right? This is not wrong. This should work just as well as how we had it before. Yeah. Malloc gives us a pointer. Malloc gives us a pointer back. Right now, it's not a pointer. How do I make it a pointer? Yeah. I got to add that star to the type. So it's going to give me back a pointer to this array. Right? And so now, let's think about how we want to use this function that's going to add an element to this array. So what are we going to do? We're going to call it, what? Add element. Let's say that's the name of our function. What do I need to give this function to do its job? What pieces of information do I need to tell this function in order for it to do its job appropriately? What does it need? Adding an element to an array, what does the function need in order to add an element to an array? It needs an array, right? It needs an array. In this case, we're going to use that array that we just malloced. What else does it need? It needs the element that we want to add. What are we adding to it? So in this case, we can just make it up, 7. I'll just use 7 for now. That could be literally anything, any integer, right? So this kind of gives us a hint as to how we want to define this function, how we want to define this add element function. So let's take a look at that next. Let's define our function and try to write some pseudocode for it. Do I have any return type? Do I have any return type here? Right now, no. Do I need one? Do I need to return something from this function? No? I think you could maybe take it both ways. I think we could maybe go either direction with it. In fact, why don't we hold off on that for now? I'm going to call it void. I'm going to call it void for now. I'm going to say there's no return type. But I might come back and change that later. I kind of want you guys to think about that a little bit. Maybe when you're working on it in a few minutes, you'll have a different idea, something we can do. So the next thing that comes is the name of the function, element. And now I have to define my inputs. So my first input is an array, but we're not allowed to use brackets. But fortunately, we've already talked about this problem, right? I can define it this way, and define it that way. So we'll say int star a. The second input has what type? Has an int, and we can just give it any name that we want. Okay. So now I want to write some pseudocode for this guy as to what we need to do. Remember, right now, if we think about what we've got set up, A has enough room for 0 things. A right now is holding 0 things, and it has enough room for 0 things. It has like literally 0 memory allocated to it. So before I can add this element to it, what do I have to do? What do I have to do first to get get enough space to add this element? Yeah, in the back. I'm sorry? Yeah, so we need to allocate more space, right? We need to allocate more space. How much space do we need to allocate? This is maybe the tricky part. So allocate enough space for new elements. But we want to be a little bit careful. I can't just allocate enough space for one element. I want it all to be together. So I need to allocate enough space for the entire array. So the entire array is going to be 1 larger than it currently is. Am I keeping track of how big this array is anywhere? This is where things get a little bit tricky, right? I'm not keeping track of how big this array is anywhere, right? I have no idea how large this array is. And I don't have a very easy way of figuring it out. Anybody think of a way that we can track the size of this array as we go through this stuff? Yeah. I'm thinking, so printf is a good idea if we want to see, and we actually will do that towards the end, but I'm thinking more along the lines of how can we track the size so that we know how much space we need here? What can we use to help us track the size of this array as we go through? A variable, what kind of variable is it going to have to be? Can I just do it right here? Can I do it right there? Is that okay? What if I also want to use, so I said I wanted to get rid of this 4, right? So using a variable here is great. Where am I going to get this variable from? What kind of variable does it have to be? There's a couple answers that I think could work here. A couple answers. Pointer? What did we do for pset 3 when we had something that needed to be referenced across many different functions? How do we solve that problem? Global. Very global. We could use a global variable here. I know that I'm on record as saying I'm not a huge fan of global variables. In this case, I think it's a pretty good solution to the problem that we face. An alternative solution might be using the return type to return the size of the new array. You could play around with that as well, see if that works. Right? So we can't, the one thing we can't do is this. This will not work. Right? This will not work. But if I make it global, I can then reference the size here, and I can also reference the size in this function as well, so I know exactly how many things I have to print off. Where am I going to set this value for the first time? Where does that go? I need to give this its initial value, right? So where do I set? So for example, what should the value of size be after I do this? 0. So why don't I say that here, right? Size equals 0. And now when we say allocate enough space for a new element, we have this size variable that we can use to help us do that, right? We have that size variable that we can use. All right. So we have our size variable that we can use to allocate space. Once I allocate that space, what am I going to have to do? What am I going to have to do next? So I have this array coming in. I've just allocated enough space for a second array. So I have 2 arrays now, correct? I have 2 of them. I have this one that's coming in, and I have this one that I just mallocked. So I have 2 arrays. So what do I need to do next? I have 2 arrays. That's important, actually. I mean, I think that might be worth talking about. When I allocate this, or I allocated this here, right? This allocation is going to create a second array. I cannot reallocate A. Why not? Why can't I reallocate A? Because A already has a bunch of stuff in it. So what's going to happen if I reallocate it and it's already got a bunch of stuff in it? Bye-bye stuff, right? No more stuff. If I have an array that's full of stuff and I say reallocate that array to do something else, all that stuff's now gone. It's just gone. I can't get it back. Bye-bye. Bye-bye stuff. So I have to make this a second array, and then what am I going to have to do? Yeah. I'm going to have to copy. I'm going to have to copy it all over. I'm going to have to copy all that stuff over. Does that make sense? Does that make sense why that's necessary? I can't reallocate A, because otherwise I'll lose all my stuff. So I allocate enough space for a second array, and now I have to copy it all over. So how am I going to copy it over? What structure am I going to likely need to do that? A loop. So for each element in A, copy it to new array. So now we have a copy of A. Have we added our element in yet? Not yet, right? Not yet. So add in new element. So we allocate space that can hold one more thing. We copy everything over. We add in our new thing. Are we done? What do you think? No? What are we missing? We need to... Right. So we've got two different arrays here. So our result is actually this new array, right? This is our result, is that new array. A, after this point, is worthless to us. We don't need it anymore. It's worthless to us. So we really want B, right? We really want B. So maybe for our return type, we want to, or I'm calling it B, I mean our new array. Return the new array. Maybe that should be our return value. We're going to return our new array. I'm going to let you think about that one. I think I've gone on long enough about this problem. This pseudocode will get the job done. Figuring out how to implement it, on the other hand, is going to be a little tricky. Remember, no brackets allowed. Not for this one. See if you can figure it out. We'll go through the solution in 5 to 10-ish minutes. Okay? Alrighty, let's see if we can't start piecing this one together. So the first thing on our list of stuff to do is to allocate enough space for a new element. Actually, technically, it should be allocate enough space for an entirely new array, right? So how do I do that? What do I need to type? Somebody help me out here. What am I going to do? Oops. So I heard something size equals size plus 1. Is that what I heard? So increase the size to indicate that we've got an extra element in there. Okay, now what? Now what do I do? How am I going to get memory for that new array that we have to do? malloc, right? So we need to call the malloc. And what am I gonna request here for the size, for the amount of memory we need? How am I gonna say that? Size. Is that enough? Are we good? Times size of int. So this is how many things I want, and this is the element that I'm storing. And then the result of malloc, we said earlier, is a pointer, correct? So I need to create a new pointer for this. I'll just call it v. Whoops, forgot to make it a pointer. So I'll just create a new pointer for it, call it v. Okay? So far, so good, right? Any questions? We good? So now we can do this next part. We need to create a copy, right? So for each element in A, we need to copy those values over to the new array. So I think we need a for loop here. Int I equals 0. I less than what? Size minus 1, because we increased it by 1. We increased it by 1. We need to make sure that we take that 1 into account. I plus plus. And then how do we copy those things over? What's that statement look like? How do we say that? I'm taking the values from A and copying them over into B. So how do I reference the value that I want from B? Yeah, go ahead. Star paren A plus I. Oops. Close. But backwards. We just got to swap these guys. Just got to swap those guys around. So what does this mean? Follow the pointer, right? A is kind of our base address. A is sort of like a base. I, in this case, is behaving as an offset. You might hear I referred to as an offset. So A is a base address, and then I is an offset. B is also a base address, and then I is acting as an offset. Right? This will successfully copy A over to B, and then we've got that one spot at the end, right? We've got that one spot at the very end that we can use for our new element. How do I say that? How do I add that new element in there? Star B plus size equals n. Are we okay with this? Are we okay with this? Size represents how many elements I have, right? So if I have 10 elements, size will be 10. Is that right? We good? I was waiting. Yeah, size minus 1, right? If I have 10 elements, the index of the last one is 9, right? So it's got to be size minus 1. Does that make sense why that's the case? I hope it does. Got to be size minus 1. Okay? So let's see. Let's refer back. All right, so we're actually about there. And now we just need to return this new array. So that should be pretty easy, but we've got some other stuff we need to do. Return, the new array is called B, so I'll just return B. But that changes some things, right? This is no longer void. What is it now? It's now in star, so we need to make sure that that type is appropriate. And then up here, you see I call this function. Am I using that return type right now? What's happening to this return value? I add the elements, I create that new array, I give it back, and then where does it go? It just fizzles out, disappears, off into the ether. So what do I need to do instead? How do I fix it? How do I fix that? I don't need to create a new one. I mean, I could, but I don't really need to. Why don't I just reuse the one that I got? Let's do that. Can I drop it into the print array part? You mean take this whole thing and drop it in there? Is that what you're asking? You certainly could, but I don't want to just add one element. I want to add a bunch of them. So I'm going to add a whole bunch. Which makes it a little better to do things this way, right? Et cetera, et cetera, et cetera, et cetera. Question? Sure, you could replace this with a getInt, absolutely, and then have the user type in what values they want, absolutely. Actually, this would be a great exercise for if we wanted the users to type in a series of numbers, but we have no idea how many numbers they're going to give us. This would be great for that. Does that make sense why this would be a perfectly suited approach? Because we have no idea how to make that array. The user could give us 10 values, they could give us 100 values, they could give us 1,000 values. We have no idea how many they're going to give us. But with this approach, it doesn't matter. Because whenever we find out we need more space, we just say, hey, give me some more space. It gives us more space. And then we add that new element in, right? So we don't have to guess how many values the user is going to give us anymore. We can just dynamically ask for more room when we need it. Does that make sense? Does that make sense? We haven't tested this yet. I think, did I make the prototype? I didn't make the prototype, so let me do that. Let me make this prototype up here. And we haven't tested it yet, but we should do that. So I think we could do it now, unless I'm missing anything. Are there any questions or any concerns before I actually try to test this out? Make sure that it works. Let's try it. Make array print. Oh, let's save it. How about that? Make array print and then array print. Hey, 7, 9, 10, 2. That looks like it worked pretty well. Looks like it worked pretty well. Are there any questions? Yes. Why do I return B instead of returning star B? So what does the star operator do again? What does it do? It goes to the location and returns the value, right? So if I return star B, what am I actually, we can try it, right? What am I actually giving back if I do that? Oops, I forgot to make it again. So for starters, it gets mad at me. Star B is going to say, go to the address that B is pointing at, find whatever value is there, which is going to be what, an integer? And then it's just going to give that back. So I'm not going to get the array. I'm just going to get one value. I'm just going to get the very first value back. That's what star B is going to do. I mean, you can do it. You can definitely do it. There's nothing wrong with doing that, as long as you update your return type accordingly. This would compile and run, I would think. I forgot to change my prototype. I think this would compile and run. No. Oh, wow. Let's do something else. Oh, well, so now we have another problem. Because this is an integer pointer, I can't set that to an int, right? That's a pointer. It's not an int. So I'd have to change this to be an int. And I'm not going to do that. But, yeah, so to answer your question, B is the pointer. We specifically asked to return a pointer. We want a pointer to the array. We don't want just the first element. We want a pointer to the first element so that we can get the whole rest of it. Any other questions or concerns? Yes? Yeah, let's try it out. So you mean something like this, the old array pointer to the new, like that? So we don't need the return type anymore, right? We can just say void. And then up here, we just take all these off. Let's try it and see what happens. Okay. I think this makes sense. So we just set the old value to the new one, right? And then A should just keep updating as we go, right? That's the idea. Let's try it out and see what happens. Did I save it? I did. Okay. So, all right, I got an error. Let's see. Oops, I forgot to change my prototype. I always do that. You guys always do that? I always do that. I just forget to change the prototype. And what happened? Oh, thank you. Yes. Thanks. That's better. All right, that time it compiled. Let's try it now and see. Whoops. So, okay. So I have 4 values, but they're all zeros. What's going on here? Does anybody know what's going on? Anybody know what happened? It seemed like our logic was sound. It seemed like that should work, right? Seemed like that should be okay, but it's not. Why? So when I pass A in, I'm passing A in here, right? How am I passing it in? I'm passing it in by value, which means what? It's just a copy. It's just a copy of the pointer. So I can change the pointer all I want, but I'm changing the copy of the pointer. I'm not changing the original, which is up here. I'm not changing that original pointer. Okay? Could I fix that? Is there something I could do to fix that? We're kind of taking a little deviation, but I don't mind too much. Could I fix that somehow? Yeah. Amp A doesn't work in C. That's a C++ thing, I believe. Pretty sure that's a C++ thing. I mean, I can try it. Fairly certain that this will not compile. But let's see. I've been wrong before. Yeah, it's really 10 errors. I'm really not happy with that change. I believe using that ampersand syntax in a function definition is C++, not C. Does not like it there. But you're kind of on the right track. So what was the idea? The idea was I want to pass it in not by value but by reference. Your mind's in the right place. It's just that's not the right way to go about it. Yeah. Should I dereference A and B? You mean like down here? So what's the dereference operator? Yeah, I know. What's the dereference operator though is the question. How do I dereference something? I'm sorry? Star? So I could say star of A equals star of B. Let's try this out and see if that gets us any closer. So compiles and okay, closer. What happened? What happened there? What does it mean to dereference A? What does that mean? So we kind of just talked about this, right? I just talked about this a little bit. When I say star B, what am I actually doing? I'm grabbing the value that B is pointing at, which is the very first element in the array. So it's pointing at the actual value in the array. It's not pointing, we need the address, right? We need the address. We need the address. So, good idea. Not quite going to cut it. There actually is a way. I don't think it was covered in the prep work that you guys had to do today, but there is a way to make this work. And it's kind of a mind-blowing thing here. What is it? So I just added a second star here. What does that mean? A pointer to a pointer. I've got a pointer to a pointer. So how does that help us? How does that help us here? Yeah. So I'm still passing this by value, right? I'm passing a pointer to a pointer. But now if I follow that pointer, if I dereference this pointer to a pointer, I'm going to get a pointer back out, right? And so then I can change that pointer directly. I know we're kind of off in another dimension at this point, right? We kind of flew off the rails a little bit here. But this is, if you really want to do it this way, that's the way that it works. That's the way that it would work. So how would that work then? I think we would put a star out in front here. I could be wrong about that. Oh yeah, I screwed that up. Oh, well, so now, it's not, well, hang on a second. Let me think about this. I did something wrong. Oh, so now A is no longer a pointer. It's a pointer to a pointer. So what does that mean then? We have to dereference A every time we use it? That's kind of annoying. What did I do wrong now? Oh, my prototype. Yeah, it's my prototype now. It's always the prototype. Why do I even ask? It's just the prototype. I always forget the prototype. All right. Still not happy. See, we have got ourselves in, we've dug ourselves in a hole here. Dug ourselves in quite the hole here. What is it mad about? Incompatible pointer types, passing int star. So, see, now I'm passing, all right, so now I'm passing in a pointer to a pointer. How do I get, A is just a pointer. How do I get a pointer to the pointer? How do I do that? Ampersand A. Just put stars everywhere and it'll work out, right? That's kind of what it feels like sometimes with pointers. I would strongly encourage you to resist that urge, even though it's a very powerful, hey. So it compiles, but nah, that doesn't mean anything if it doesn't work, right? Oh, it does. It does. It does. So that was not in the prep work today. If I lost you, don't worry about it. Don't worry about it. But let me explain. I mean, because we did spend all this time on it, I want to make sure that we understand what happened. I pass in a pointer to a pointer, right? A pointer to a pointer, which allows me to then come down here and say, go find that pointer value and change it to be B. So now I'm actually, setting B, or I'm taking B and I'm replacing A. So whatever A was pointing at, it's now pointing at B. It's pointing at the brand new array, right? It eliminates the need for the return type. I now have void here, okay? So I passed in a pointer to a pointer. That allowed me to manipulate the pointer directly. Does that make sense? Instead of a copy of the pointer. That's really the secret. And then in order to make it work, here I couldn't just pass in a pointer. I had to pass in a pointer to a pointer. So I had to dereference A, or grab the pointer to A to make this work. Yeah. Welcome to pointers. It's a lot of fun. Let me put this back to how it was, because that's the version that I want to post online after class, is the way that we had it before. All right. If I keep hitting undo long enough, eventually I'll get there. Yeah, we did that. All right, I think, oops. All right, take this off. I think we're good. Let me just double check this and make sure that it still works. Nope. Oh, I got to return something. Thank you. Thank you. I'll return B. All right, let me just make sure that this still works. All right, cool. This is the version that I want to put up. If you didn't understand that whole pointer business, don't worry too much. That was not my goal for today. I thought it was a fun little side trip, but not the main premise that I wanted to get across today. Are there any other questions for me right now? Any other questions? There's one other thing, actually two other things that I wanted to talk to you about. We got a little bit of time left. So in this version, our original version, I'm creating a whole second array called B, right? Creating a whole second array called B. I copy everything over to B, and I set the new value to B, and then I return B. What happens to A? Where does A go? Where does A go? So I never refer to that original array again, right? Where is it? It just disappeared. It's chilling. It's just chilling in memory. Taking up space. Taking up space. This was also very, very, very briefly mentioned in the prep work for today. It's going to be covered more extensively, actually, in the prep work for class 2. But anytime I use malloc to allocate memory, that memory stays allocated forever until I say, oh, I don't need this anymore. So I actually have to say, no, I'm done with this memory. You can have it back now. You can use this for something else. The way to do that is with a command called free. So I really should free A here to get rid of that old version. And then actually at the very end of this, I should also free A to free the last array. I know we didn't cover that today, but this is so engraved into my brain that I would probably lose sleep at night if I didn't do this right now. It just bothers me that much. I have to free it. I have to. I can feel it in my bones. It's got to be free. It wants to be free. So anytime you see malloc, you should have a matching free statement to go along with it. That's sort of the moral of that story. You're going to read more about that when you do the prep work for Thursday. I feel like there was another question I had for you, but I forgot what it was. I'm sorry? Is that going to free A twice? I do have it in the function, yeah. I do have it in the function. But it's important that it's in both places. It's important that it's in both places. When I say free A here, I'm freeing the old small array that I don't need anymore, and then I have this brand new copy that I created, right? But then eventually, when I finish, I've got an array left over. So create a copy, add an element, right? Create an array, add an element, create an array, add an element. At the end, I still have one left over, so I have to free that one too. Does that make sense? So every time I call this, I'm creating a new array, new array, new array, new array. Print it out, free it, right? You should always, it's a pretty good rule of thumb. Anytime I call malloc, there should be a corresponding call to free at the end somewhere. That's a pretty good rule of thumb when dealing with malloc. Any other questions? Any questions? We do not have time for this last problem, since we only have 10 minutes. But I do want to talk about it really quickly, just in case any of you feel like tackling it. It is a bit more challenging. Whoops, I chose the wrong slide, of course. Let me fix that. It is a bit more challenging than the one that we just did. So it's basically the same thing, but in reverse. Write a function that removes an element from an array. So we did one that adds an element to an array. Now, if we want to go in the opposite direction, so we want to shrink the size of the array, but it's a little bit more complicated because we first have to see if the element's even in there, right? So we first have to find the element, or we have to search for it. We know how to search for things, right? We know how to search for stuff. So search for the element. We either find it or we don't. If we don't find it, then we don't have anything to do. If we do find it, then we kind of have to do what we did, but in reverse. I have to allocate for one size, for one element less, one smaller, and then copy everything over, making sure not to copy the value that I want to remove. Does that make sense? This is a tricky one. We do not have time to do it in 10 minutes. It just would not happen. But that's kind of the process. There is a way to do it without brackets. You should be able to use the add function that we just did as sort of a starting point for that one. That will get you kind of pushed in the right direction. So if you want more practice with pointers, I think this would be a good one to try. Are there any questions? Any questions for me right now? If not, I know it's not quite 7, but I'm going to go ahead and, I guess, stop it here. We do have a studio for you to work on today, word grid stretch. I do want to give you a word of caution. You may not actually need to use pointers to solve this. Could you use pointers to solve this? Sure. And if you want practice with pointers, I think that might be a good thing to do, but you don't actually need pointers to solve it. I'm fairly certain of that. You will need pointers for the problem set, however. So you can also get started on the problem set. One final thing I want to mention, in about 10, actually less than 10 minutes, there's going to be a talk in the classroom on some advanced C concepts. I believe Rob is giving that talk, am I right? Yeah. So Rob's going to be giving a talk. How long is that going to be, Rob? Half hour? 45 minutes? Okay, half hour, 45 minutes talk on some advanced C concepts. Anything in particular you're planning on? Okay. So just to recap what he said, in case you didn't hear, he's going to talk about some more advanced printf stuff. He's going to talk about enumerations, and he's also going to talk about some advanced conditionals like switch and the ternary operator, all things that we have not talked about at all. So if you think any of that stuff sounds cool, you should make your way back to the classroom at 7 o'clock. Once the review session is over, Rob's going to take over and talk about some of that stuff. Otherwise, we'll go ahead and wrap this up for now, and you can get started on the studio. Let us know if you have any questions. Thanks.